So in this problem, we're again going to be converting between recursive and explicit formulas. But this problem's a little bit more challenging because it does not match up to the general formula for either explicit or recursive. So let's just remind ourselves of what that general formula is for the explicit formula, at least, since that's what we're given. And we have that f of n, our sequence f, is equal to the first term of the sequence multiplied by the common ratio r raised to the n minus 1. Where again, r, that's just our common ratio here. And you can see that's not what we have. We have that this is raised to the nth power. So we can't just compare it to the general formula to figure out the first term and the common ratio. We need to come up with a different approach here. And for these problems where it doesn't match up to the general formula, the general advice is to just regenerate the sequence and figure out the patterns from there. So usually this number out front, this is the first term. But when it's raised to the n power, it doesn't work that way. So let's find that first term. If we plug in 1, an n value of 1 here, we get 2 multiplied by minus 3 to the first power. And anything to the first power is itself, so we get 2 times negative 3, and that's negative 6. So in this case, our first term is negative 6. Let me start writing these down here, and we'll generate the rest of the terms. So the second term, if we just plug in n equals 2, we get 2 times minus 3 to the second power now. And minus 3 squared is positive 9, so 2 times positive 9 is 18. So positive 18 is the second term. And we'll do one more just to prove the pattern. So f of 3, we get 2 times minus 3 to the third power. And minus 3 to the third power would be negative 27. And if we double that, we get minus 54. So hopefully now you can see the pattern that going from one term to the next, we are multiplying by negative 3. So it looks like our common ratio is still in this equation where we'd expect it to be. This still is our r value, but it's that first term that's not correct. So if we wanted, we could find the next term by just continuing the pattern. It'd be minus 54 times negative 3. It's a positive number. And 3 times 50 is 150. 3 times 4 is 12. So you get positive 162. And of course, this is going to go on forever. So from here, once we have the actual sequence, now we can find the recursive formula. And if you didn't notice the pattern of what you're multiplying by, going from term to term, we could also find that by just taking one term and dividing by the number before it. We can choose any term we want. So let's go with the smaller numbers. 18, now we divide it by the term before, negative 6. And so you get negative 3, which is what we noticed. And we know that in our recursive formula that, well, this is our first term. And we found that is negative 6. So we can put that into the box. And in our pattern here in the recursive formula, to find the nth term, you take the term before it, the n minus 1 term, and then multiply by that common ratio r. And we found that common ratio to be negative 3. So this is what we think is our recursive formula. But let's check our work. And let's just find the second term in our recursive formula. Since we know that the second term, we found that earlier, that's going to be 18. So plugging that into our general formula for this recursive formula, we have f of 2. So n equals 2 here. So we have f of 2 minus 1, which is just f of 1, multiplied by negative 3. And the first term we know is negative 6. And negative 6 times negative 3 would be positive 18. So we got what we expected, which means we can feel confident that these numbers are correct. Though if you really want, you can go one step further, plug in n equals 3, so that'd be the second term multiplied by negative 3. And we know the third term, we found that earlier with our explicit formula, should be minus 54. And going back to this recursive formula, the second term we know is 18 multiplied by -3, and that is minus 54. So in both cases, when we checked it, our recursive formula matched up with the explicit formula that they gave us.